Applying a mode to a target in 3D often requires two steps of selection, one for selecting the target and one for selecting the tool. As a result, the interaction requires the user to shift their visual attention away from the target to select the tool. This gaze shift, which may not be comfortable in many applications, is hard to eliminate as target objects and menus are typically presented at distinct locations in the scene. However, 3D user interfaces afford direct operation of objects using users' body and hand movements. We introduce EyeSeeThrough, an interaction technique for VR that leverages eye tracking to streamline the two-step operation by utilizing the ability to align the object and tool relative to each other in 3D. With EyeSeeThrough, the user brings the menu towards the gaze whilst looking at the target. Once the tool is visually aligned with the target, the user issues a confirmation command. This allows the user to maintain their visual attention on the target during the interaction. This demonstrates the technique in VR. We compared our method with the baseline two-step selection performed by gaze with a handheld menu where the alignment is performed by the hand, and also when the menu is attached to the user's head and the alignment is performed by head rotation. The results of our user study showed that the EyeSeeThrough technique outperforms the two-step selection in terms of speed and comfort. We further developed a prototype of a virtual living room to demonstrate the practicality of the proposed technique, explore its design space, and discuss some design considerations of the technique. A table light is an example of a basic interactive object that has a relatively small size, which allows the menu items to be presented around it. The menu has an on-off button and two other buttons for adjusting the brightness of the light. The television object has more options available in the menu, and due to its size, multiple tools may be overlaid simultaneously. With EyeSeeThrough, the gaze implicitly defines the intended tool. A color-changing light shows the feasibility of EyeSeeThrough for controlling two continuous parameters simultaneously, such as the brightness and the color of a light. Here, the user can adjust the color and intensity of the light by moving the tool and looking through any particular area of the menu. Lastly, with an interactive door, we show a combination of a binary button that teleports the user to the other room and a one-dimensional slider for gradually closing and opening the door.